Hello guys, my name is Bob. In this video, I will be showing you the solution to the Maclaurin series of ln 1 plus sine x. But before I do so, if you guys liked the solution, help me press the thumbs up icon below this video so as to bring this video out to the top of the search and more people will get access to this video. We are going to express the ln 1 plus sine x as a Maclaurin series up to and including the x to the power 4 terms using the top right hand corners formula. The top right hand corners formula tells us that a function of x can be expressed as an infinite series. Before we are able to apply the top right hand corners formula, we first need to find what is my f0, where f0 is the function evaluated at x equals to 0, f prime 0 is the function differentiated once and evaluated at x is equals to 0, f double prime 0 is the function differentiated twice and evaluated at x equals to 0, f triple prime 0 is the function differentiated 3 times and evaluated at x equals to 0, and last but not least we have f differentiated 4 times and evaluated at x equals to 0. So right now we define what is my function of x. We let our function of x to be ln 1 plus sine x. And then we find what is my f prime x. So my f prime x is just equals to 1 plus sine x. And then we differentiate 1 plus sine x. So this gives me cosine x. We next find the function of x differentiated twice. How do we go about doing that is we will use the quotient rule, so which is 1 plus sine x squared, and then we bring it up here, we have 1 plus sine x, and then we differentiate cosine x, which is negative sine x, subtracting away, keeping cosine x, and then we differentiate 1 plus sine x is cosine x. To simplify further, here is what we have. We have negative sine x minus sine square x minus cosine square x over 1 plus sine x squared. Okay, in which it can be further simplified into the following. My sine square x and cosine square x is just 1. And then we are able to simplify further, in which my f double prime x will be just negative of 1 over 1 plus sine x. We next find what is my f triple prime x. So to find the f triple prime x, we will just use the quotient rule again, in which my denominator will be the square of 1 plus sine x. And I bring out 1 plus sine x, differentiating 1 is 0, subtracting away, keeping 1, differentiating 1 plus sine x. This will give me cosine x, in which this is just equals to cosine x over 1 plus sine x squared. And then last but not least, we will differentiate the function 4 times. So how do we go about doing this? Same thing, quotient rule. We are going to square 1 plus sine x squared. So we get 1 plus sine x to the power 4, bringing up 1 plus sine x squared. Differentiating cosine x gives me negative sine x, subtracting away 2, 1 plus sine x. And then we differentiate 1 plus sine x, we get cosine x. Times cosine x, right? And after which we'll evaluate this function at x equals to 0. So we have f0, and then we have f prime 0, and then we have f double prime 0, f triple prime 0, and f 4 times prime 0. Okay, so let's find what is my f0 first. So f0 is substituting x equals to 0 into the function of x. We get just basically ln 1 plus sine 0 is just ln 1, which is 0. And if we were to next substitute x equals to 0 into f prime x, we get in the denominator 1 plus 0 is just 1. And then in the numerator, cosine 0 is basically just 1. So 1 divided by 1 gives me 1. The next step, we are going to evaluate x equals to 0 in f double prime x. In our denominator is just -1, numerator is just 1, so f double prime 0 is -1. F triple prime 0, sine 0 is 0, so 1 plus 0 is 1, so we get in the denominator is 1 squared. And then in the numerator, we know that this is already 0. And my cosine 0 is 1. So -1 times negative gives me 1. So this is equals to just 1. And last but not least, we substitute x equals to 0 into this function. So in which my denominator is just 1 to the power of 4 is just 1. So we focus on the numerator. In the numerator itself, we have the first term to be 0 because sine 0 is 0. So anything multiplied by 0 gives me 0. Whereas for the second term, we have 1 plus sine x is just 1. If we were to substitute x equals 0, and then cosine x times cosine x gives me 1 when x is equals to 0. So the final value for f 4 times prime 0 is -2. Once we calculate f0, f prime 0, f double prime 0, f triple prime 0, f 4 times prime 0, we will then apply the formula in the top right hand corner to determine what is the Maclaurin series of ln 1 plus sine x. So the Maclaurin series of ln 1 plus sine x up to and including the x to the power 4 terms would be just f0 is 0, so we do not write anything down. F prime 0 is 1, so 1 times x is x. F double prime 0 is -1, so -1 divided by 2 factorial is just half, and x squared. How about my x cubed? My x cubed would be substituting 1 into the f triple prime 0 divided by 3 factorial, so 3 factorial is 6, and then we have x cubed. And then last but not least, we have f 4 times prime 0 is just 2 over 4 factorial is 4 times 3 times 2 times 1 is 2 over 24. So in which, if I were to simplify this, I will get the following, which is 1 over 12. And then x to the power 4. And then this will be the final answer to the Maclaurin series of ln 1 plus sine x, which is approximated to be x minus half x squared plus 1 over 6x cubed minus 1 over 12x to the power 4. If you guys like the solution, help me press the thumbs up icon below this video and do consider to subscribe. My name is Bob. Thank you guys for your support. I will see you in the next video. Goodbye guys.